Yeah, thank you. So, welcome to the first session on blockchain. And today we're going to talk about smart contracts and some details on how Ethereum works. Because, as you know, perhaps already, as soon as you completed all your assignments so far, Ethereum works using smart contracts. And today we're gonna learn something more how these smart contracts work and how you can implement a smart contract. And looking forward in your next home assignment, you will need to write your own smart contract. So listen carefully, and Ma, or as I learned, also Jeff, also Menjong, will present today this wonderful lecture. Okay, floor is yours.
Yeah, thank you, Tim. So this is gonna be the second blockchain course or third blockchain course. And today we're gonna mainly talk about what is the Ethereum blockchain, its structure, how it's working, how to submit the transaction, and how to make your first smart contract and interact with it. So let me share my screen. Yes, and yes. Okay. So so let's step into the Ethereum blockchain by know how it's different from the Bitcoin blockchain. So the Ethereum blockchain is actually also a decentralized system, and is supported by many nodes. And similar with the Bitcoin blockchain, all the nodes will operate a similar system that store the similar data so that although any one of the node may be damaged, but in aggregate, um, we can get the correct transaction history from the nodes, from the other nodes, okay? And as we can see from the slides, it's a distributed system. And there is a token on it, which is called ETH. And the purpose of this token is different from the Bitcoin blockchain. On Bitcoin blockchain, the Bitcoin is itself the purpose of the blockchain, which means that people are using this blockchain to transfer the token. And it's a purely network for peer-to-peer payment. But for the Ethereum blockchain, Vitalik designed it to achieve the first blockchain for Turing complete computation, which means that you can regard the blockchain as the distributed computer and uh, deploy the script to do some certain task and do some programming. Okay, so as you can see that because the purpose of the Ethereum blockchain is to do some computation and the programming, so the ETH, the token on it, is not for transaction itself, but for paying the computation resources, which means that every time you use the distributed computer, you need to pay the node, right? Because you're actually using the service provided by node, and the node is giving the computation power, and you need to pay them using the token, which is the ETH, okay, ETH. Um, and the basic structure is that there is the global shared state, which you can regard it as the shared memory or the storage. So as you can see that from the last lecture, the blockchain is the chained block, right? So there are many blocks, and in each block there will be a bunch of data, and the data will be chained by the in some certain way, and because the data are structured block by block, so they are organized in a discrete way, and every time there's a new block, history or the status of the blockchain would be changed. And uh, so every time there is an update, uh, there may be some new things or there may be some delete of the previous things. And if you want to change something like deploy a new smart contract, you actually add some new things to the shared memory. And if you delete, okay, the same case. Okay, that's why the new Ethereum blockchain is actually a complex version of the Bitcoin blockchain. And although the current version of the Ethereum blockchain is based on the proof of staking, the previous one is the proof of work. Yes, and another thing is that the address means not only um, the public key, as we talked about in the last lecture, it represents some other things. As you can see from the slides, there are two types of accounts. One is the EOA, which is the public key generated by the private key, and you can use this account as your something like a wallet. You can store some ETH, the token in your wallet, and pay the transaction, or you pay some others with the ETH. And another is the contract account, which means that if you deploy a certain program, which is called a smart contract on the Ethereum blockchain, you can interact with it. And to interact with it, you need to refer it with something, and this referring is actually is a kind of address, and we call it a contract address. Okay, so there will be two types of the account or the address. One for the person or the users, and another for the smart contract or the program. And okay, another thing is that because now we are executing functions or the program on the shared blockchain or the distributed computing system, so there should be a virtual machine to execute the smart contract, which means that the virtual machine can convert the human readable codes to the machine readable codes, to the byte codes, and then let the shared computer to execute the codes and then store the result of the executed codes. Okay, so the part that doing this job is called the Ethereum virtual machine, and we call it the EVM for short. And then the next important point is the consensus blocks. So here in this lecture, because I mainly focus on how you interact with the chain in practical, so I just briefly gonna talk about how the validators on the Ethereum blockchain is doing consensus, which what the means or what the meaning of a consensus. The consensus is actually similar with the case in the last lecture when there are three pairs of nodes, right? And they are comparing the result with each other and determine the aggregated history. It's like if the majority of the nodes have the same history, then this history gonna be regarded as the correct history. And similar with the case here, so many nodes will execute a code and they compare the result of the code. And then if a majority of the nodes agree on a certain result, then this result will be put into the block and add to the blockchain. And then, as I have described just now, if you now understand that the Ethereum blockchain is actually a distributed computing system, as a distributed computer, then what you are doing with the certain script or program is actually change storage. Okay, you put some new data, and through the certain program, you generate some result data, and the result data, if you store it permanently in the system, you're going to change the storage. And deploy the smart contract itself is actually a changing of the storage. Okay. And doing so, you are consuming the computation power provided by the node. So that's why there will be a storage cost. And you pay it using the ETH, okay, which is the native token of the Ethereum blockchain. Um, and then because it's a computing system, right? So it's has a memory, and but I won't dig into it too much. Because it's a little bit tech and the memory. If you want to know more about how to write a smart contract, you will know that um, operating on the memory inside the smart contract, if you want to assign some value to a certain variable, you need to define the variable. And this kind of operation is actually firstly define a memory uh, slot and then assign the certain value to this slot. Okay. And then account state, okay, account, we are usually interchangeable this word with the address, okay. Okay, and each account actually has a balance of ETH and the nonce. A nonce is a number of a transaction sent. Okay, we use the nonce to prevent the problem of double spending, and which means that you cannot use one account to send two transactions simultaneously. Think about the case that if you are doing so successfully, then the nodes will don't know which transaction should be put in priority. Okay, so this gonna be the problem. So the only way is that you give the first transaction a nonce, for example, one, and give the second transaction a nonce, for example, two, and then the node will know that okay, the user want me to execute the first transaction firstly, and then the second transaction. And here another difference is that as you remember in the last lecture, so the Bitcoin blockchain record the balance of the Bitcoin each address have using they need to accumulate all of the transaction to know how much of the Bitcoin you have on your address. So they do not use the balance sheet to record this, but on the Ethereum blockchain, they use a balance, something like a balance, to record how much of the token each account have. And the transaction is doing so um, by actually changing the balance for each address. Okay, so this is the main difference. And then we can see from the graph, okay, so this graph describe what is inside each block of the Ethereum blockchain. So as you may recall from the last lecture, inside the block of the Bitcoin blockchain, inside each block, there are several transfer of the Bitcoin, right? But inside the Ethereum blockchain, it's different. It's like the Ethereum blockchain in each block, it contains several transactions, and in the transaction, it actually involves how the user is interacting with the smart contract, and the smart contract itself is actually the program deployed on the Ethereum blockchain. So you can see that maybe in the block I, it records how user is calling the first function of the smart contract one, as well as the second function. So after the executing of this function, the final status will be recorded on the blockchain. And yeah, as you can see that that's why the blockchain is a Turing complete machine. Yeah, and you can deploy any kind of program you write on the Ethereum blockchain. And I can show you by code later on. Yes. Um, okay, think about the case that you write some smart contract and you want to deploy it. And actually sending any commands or data to the blockchain, we call it send a transaction to the network. Okay, so to interact with the blockchain, firstly you need to create a transaction, even if you are going to deploy a smart contract. Okay, because smart contract is also send some information to the chain. Okay, so firstly, you need to write something or okay, organize the data in some certain format and defined by the Ethereum blockchain protocol, and then signing your transaction with your private key. Okay, so this principle would be the same with that we discussed in the last lecture, right? So this is to prevent that. In the network, anybody can arbitrarily doing anything with anyone's money. So only the one with the private key can sign one's transaction. So here is the same. Okay, if you sign some transaction, which means that you are executing some commands from certain bodies or users' perspective, and especially when you are spending some money. And as you can see that and nowadays, most of the protocols on the Ethereum blockchain are DeFi protocols. So we are still doing some deals or send some funds or interact with the decentralized exchange, buy some tokens using your wallets. And if you are losing your private key, then anyone else can spend your money, okay, steal your money. And myself is I actually experienced this kind of thing. I wrongly signed uh, smart contract, and that smart contract is actually for fraudulent things, and then my money in the wallet disappear very soon, because once you are signing some function, you don't know what it is. Maybe it's gonna be a hacking function, so be care of take care of anyone, any function, any smart contract on the network you don't know. Okay. And then similar with the case of the Bitcoin network, there is a mean pool. So every time a user submit the transaction to the network, the transaction will be firstly put into the mean pool and then waiting to be selected by the builder, the block builder of the network. And then the builder will okay build his own block just like a Bitcoin blockchain, and then submit the block um, to compare, okay, who gonna be selected as the next builder, okay. So that part of the mechanism, I gonna talk about it later, okay, included in the net block. Um, okay, this page, I think I gonna move to this page directly, so it's more comprehensive. Okay, so this is the workflow of interacting with the chain. Okay, so think about the case you are a user and you send some transaction to the full node. A node here means that the node connects the user and the network. Okay, and then the full node will put your transaction into the mean pool with some other transactions. And um, then this transaction would be selected or collected by the builders. And there are several builders. And the builder here is actually doing the same thing, play the same role um, with the nodes in the Bitcoin blockchain. Okay, so the builder is actually building blocks, and then the builder sends the blocks to the relay, and you actually don't need to know what these relay or proposer is doing, because it's a little bit complicated. And this part is generated at the time when the Ethereum blockchain is shifted to the proof for staking setting. So before that time, the process of working is simpler. Okay, and you can actually check how the blockchain is working on the Etherscan. Okay, let me show you the Etherscan. Okay, Etherscan. Okay, so this is a Etherscan. And here you can see the latest blocks and as well as the latest transactions. You can click the latest blocks. So the block time for the Ethereum blockchain is the constant number. So the network produce one block every 12 seconds. So that's why we say that the Ethereum blockchain, the block time for the chain is a 12 number. And here's the hero of this blockchain. And if you click transactions, you can see all the transactions inside the blockchain. And here you can see that from to means that this user is interacting with this smart contract, okay? And if you click the transaction hash, you're gonna see the detailed information about how the user is interacting with the smart contract, okay? So this user is actually, let's see what it's doing. He's calling this function, okay, on the smart contract. And because this smart contract is deployed by a protocol, so the protocol need to um, release all of the human readable code to the public to show that how their smart contract is working and make it transparent. Okay, and also they're gonna invite some auditing firm to audit their codes. Uh, but actually, if you do not release your code, you cannot see it because on the blockchain we only know the bytecode, which is the code can be executed by the machine rather than the human readable code. Okay, then if we change to see some other things like okay, people are transfer money, you can see that they're transfer money. That's the USDC. Um, okay, maybe this one, maybe this one. Okay, okay. So for this transaction, you can say that this user is calling this function. And because this not this function, this smart contract, and because this smart contract is not a smart contract by a certain protocol, I think this smart contract is for arbitrage. Okay, it's for trading. So the deployer are not required to public release for what the smart contract is doing. So that's why we can see in the input data here that input data are all bytecode, which is not human readable. Okay, and then we go back. Then the gas and the transaction fees, okay. So as we discussed just now, if you want to send some data to the blockchain and execute some functions on the smart contract, you're actually consuming the computation power provided by the node, right? And so to do it, you need to pay. And you can indicate the price you want to pay for the execution of the function. And for some of the case, like if you are executing a very complicated task, then the computation resources required is high. But in some other cases, maybe your task is simple, then the computation power you're going to consume is low. And these kind of consumption of the computation power is measured by the gas. Okay, the gas you can you can imagine it as we are driving for certain miles, you need to spend for certain amount of the gasoline, right? And the gasoline has a price. So the total price you need to pay for a certain uh, length of the travel should be equals to the gasoline you consumed and times the price of each unit of the gasoline. So here is the same. If you want to compute how much money you need to pay for your transaction, you need to times the gasoline you used in this kind of transaction and V is the price of the gasoline, which is the price of the ETH. Okay. So now if we shift to the Etherscan, we can see that okay, we can see that the transaction fee here is how much this much is, and the Explorer labeled it as a gas price time gas used by the transaction. Okay, and the gas price is this much, so you can inverse to find out how much gas it used in this transaction. And here is a Gui, here is a is. So this is the different unit used by different okay different values, because this is the value in ETH. It contains so many zeros. So for convenient, we sometimes use the GUI. So the smallest unit is a Wei, and then GUI, and then ETH. Okay. So let me type here. So the smallest one is a GUI, and then is the G Wei. Okay. And then it's ETH. Okay. Um, yeah, let's continue. And the fee consists of two parts. Okay, one is the base fee. Okay, the base fee, and another is the priority fee. Okay, think about the base fee. Base fee is actually how much of the value at least need to be consumed. Okay, by this kind of a transaction, and the priority fee is that how much the user want to pay in extra to the validator for his transaction to be executed in priority. Okay, so this is the logic. Okay, so if you want your transaction to be executed or included in the next block in advance of the others, you need to pay more to the validators. Okay, and to pay more, you can set up a very high number in this priority fee. Okay, and in this block in the Etherscan, I think they yeah, here is the base fee, and here's the priority fee. And you can also set up a max fee. Okay, max fee is the maximum money that can be used by your transaction here. Okay. Then let's here example. Okay. Um, the logic is that the same, okay? So the gas is the amount of gasoline you use, okay? And the gas price is the base plus the tip. Tip is our priority, okay? So the total fee is equals to the gasoline you use times the price of the fee, which equals to what actually the amount is the is you used to pay for your transaction. Okay. And then we move to the core part of this course. Okay, how to write some certain smart contract, some simple smart contract. Okay, so usually we call the smart contract, we write the solidity. Okay, so solidity is one form of the high level language we can use to write smart contract on Ethereum. And there are also some other types of language because it's a high level language. Just like we are programming, you can use Python, you can use JavaScript, you can use like a Golang or something else. The similarity between them is that although you are writing in different language, at the end, those human readable language will be converted to the machine readable language, be converted to bytecode. So in the end, they are the same. Okay, and then in some of the case, okay, to illustrate, I would use the Remix IDE, which is the browser-supported IDE to illustrate the smart contract code. But in most of the case, I'm gonna interact with the smart contract or write smart contract or even deploy smart contract using Python. So I'm gonna illustrate both case for you. Firstly, with Remix IDE, and then later on use the Python script. Okay, so this is the very basic example of the Solidity smart contract. Okay, it's doing the very simple thing to store a value for you on the blockchain. Okay, and let's go directly to Remix. Okay, so here is the Remix. You can directly search for it. Okay, just Remix. Okay, search for Remix. And for the second one, given by Google, is actually the IDE I use to write a smart contract. Okay, and when you are open it, it's similar with some other IDE like VS Code. Okay, it will choose the file here. Okay, and then console. Okay, and then your script. Okay, I have already write the smart contract. Okay, so you can define a smart contract using something like class. Okay, in Python, like you define a contract. Okay, with the name about the storage. Okay, and then inside the bracket, okay, you can write something to define what is exactly in for this smart contract. Okay, I have already defined a smart contract here. And inside the smart contract, we have two functions. Okay, two functions. Firstly is to input the value to assign the value to a certain variable. And then we can check the value of the variable assigned to a variable use another function, which is called retrieve. Yes. And firstly, because we are assigning value to a certain variable, and this variable is referring to a certain slot in the memory. So we need to firstly define that slot of the memory. Then we firstly define the number, and the type of the number is the unsigned unit 256. Okay, there are many types of the number you can define. Uh, which denotes which denotes different lengths of the memory. Okay, so if you know that your number will not be that long, you can define a number as unsigned unit, maybe something like 64 with a shorter length of the memory. So in this way, it will save you the computation power and save you some money because the computing power here is very expensive on the Ethereum blockchain. Okay, so this is our case, and we have already defined a number, which is this type of the variable, and then we define the function, which is called a store, and immediately following the name of the function store, you can define the input of this function, and the input we also define it as the unsigned unit 256 number. And then we indicate that this function is a public function, which means that some other program outside this smart contract can also call this function. Okay, if you define this function as a private function, which means that you change the public to private. Okay, let's see that the private. Okay, private, which means that you can only call this this function using another function within this smart contract. Okay, we still use the public, and then we assign the value given in the input of the function to the variable we define at the beginning of the smart contract, the number. Okay, so this is the first function, and the second function is okay, now we have the number. Okay, we have the number, and then we want to see what the value of the number is. So we call the retrieve function. And then the retrieve function is the public function also. And it's a view function, which means that it doesn't change the storage or of the blockchain, or that it doesn't change the status of the blockchain because it's just retrieving some data from the blockchain. And that's why this is called a view function. And the view function will returns you some value, and this value is in some certain type, which is the unsigned integer 256. Okay. And this is the smart contract we have. And at the very beginning of the script, you need to define the Solidity compiler, the compiler version. Okay. Um, so here it means that the version should be between 0.8.2 and 0.9. Okay, between these two versions. Oh, okay. And at the left-hand side of your console, you can see the third or fourth icon is called, has a name of the Solidity compiler. And if you click it, you can see the version of the compiler. And here, this version is uh, 0.8.3, which is okay, exactly in the middle of the uh, okay 8.9 and 8.2 and 9.0. Okay, so we can use this compiler to compile the smart contract we write. Okay, and here is the compile. And when we click it, okay, when we click it, um, if no error reported, that means that we have successfully compile it. Okay, so the benefit of this remix IDE is that for most of the time, compiling it and deploying it, um, you don't need to write some other extra code. You just need to click some buttons. It's actually a very friendly user interface. So that's why I'm gonna illustrate this in advance. Okay. After compiling it, you can click the fifth icon at the very left-hand side, which is named as deploy and run transactions. And then you can see that it's an environment. Okay. You can you can choose the environment to run your smart contract. Okay. So firstly, you can run it in the Remix VM, which is like you are simulating your smart contract on transactions locally uh, using the Remix the virtual machine rather than the Ethereum virtual machine. But they are actually use the same core. So if after simulating with the remixed VM, your smart contract is successfully deployed on it. Then on the Ethereum, it should be also successfully run. Okay, and if you click the Prague, okay, the Prague, okay, Prague, the Prague VM, and then there is a count. Okay, this is the fake address that you can use to simulate your transaction. Okay, and it assumes that in this fake account you have 100 ETH, which is enough for you to pay for the gas. Okay, and then the estimated gas, we use the estimated gas to calculate to give gas or the gas fee to the node. And you can also use the custom gas. Okay, so the custom gas is like even though you executing your smart contract consume a certain number of the gas, but you instanced to give the validator a certain amount, and if there are extra left behind, the node will give the is back to you. So it doesn't matter. Okay, and then there's a button, and you can actually choose which smart contract you are going to deploy because we only compiled one smart contract, which name is storage. So there's only one choice. And then we deploy it. Okay, so in the console, you can see in this small window, a new transaction, okay, has been executed. Okay. And then we can see that in the section of the deployed smart contract, there's a new smart contract. Okay, and then we click it, we can see the detailed information about this smart contract. And the balance, which means that how much of the is stored in the smart contract. So as you may uh, recall from the slides I mentioned to you just now, there are two types of address, right? Two types of accounts. One is the EOA, which is used for the users to send transactions, to sign the transactions, to pay for the money. That one is for the users. And another types of the accounts is for the smart contract. And because the smart contract also has an amount, also has an account, so you can also store some ETH, store some money in the smart contract. Here we can see that this smart contract doesn't have any ETH. Okay, so it has a zero balance of ETH. And as we have defined, there are two functions, right? The first one is the store, and the second one is the retrieve, which is shown in here in this window. And we can use the store function to assign a value to the variable number, right? So if we want to assign the number like 25 to the number, then we can input 25 in this blank and then click store to execute. Okay. So once we click, we can see that there's a new transaction. Okay. And the detail is that we are this user 0x5b3 something is calling the smart contract named as storage and the function store with the value of something, okay? And the data is like this, okay? This is the encoded data, okay? Yeah, and then if we need some detailed information, we can see that this is the detailed information. So it's very similar with the keys we see from the Ether scan, and the decoded input is actually uh, we are assigning value to the variable number. Okay, and then after executing this transaction, we can also execute another function, the retrieve, to see what value we have been stored in the variable number. Okay, we can click this button also, and then it returns us a value 25. Okay, and here, as you may say, when we click retrieve, the transaction is different from the one we click store. When we click store, there's a green point, okay, green point. And when we are click retrieve, there's no green point. And if you say the detailed information about the second one, we can see that there's no information about the gas fee, okay? But if we check the detailed information about the first one, there will be some detailed information about the gas, okay? How much gas, the transaction cost, the execution cost, this kind of thing. So what's the difference between these two kinds of transaction? The one without the green point is called the call transaction, which means that we are only retrieving information from the blockchain. We are not changing the status of the blockchain. So that's why we don't need to pay gas fee to the nodes, okay? Because we didn't use their computation power. So we don't need to pay for the computation fee, okay? But for the first case, this transaction with the green points, we are actually change the status of the chain because we are adding, we'll assign a new value to the variable on the smart contract. So we are actually changing the status of the chain. So we actually consumed some we actually consumed some computation power, so we need to pay for it. Okay, so this is the difference. And this is a very simple case of how to write a smart contract. So in this case, we're actually uh, simulating, okay, simulating using the local virtual machine. We can also deploy it on the real chain, but I will not deploy it on the real Ethereum main network, but I can deploy it on the test network, which is called Symbolia Ethereum. Okay, so to do it, you firstly need to have some Symbolia ETH, which is the native token. Okay, you need to use to pay for the gas fee on the test network. Okay, as you can see from my account. Okay, so another thing I need to introduce the MetaMask. Okay, MetaMask here is an extension on the browser which can help you to manage your uh, Ethereum account. Okay, here I have many Ethereum account. Okay, um, and if you search MetaMask, you can see something. It's a crypto wallet. So you can use this crypto wallet to connect with some decentralized application and interact with the applications. You can use this wallet to pay for something you want on some decentralized protocol. Okay, so this is a very helpful tool to participate in the crypto world. And here, as you can see that this account, let me change. Okay, change to this account, account six. Okay, account six has an address of this, and here as it's shown, it has some balance of the Symbolia is because I have already shift the network to the Symbolia network, to the Symbolia networks, to the test network. And then, but if you don't have the Symbolia is, for example, my another my another account, the account 4, you can ask for some test token in the some website. For example, the website is Faucet, and you can search for it. Just search for the Ethereum Symbolia Faucet, and the first one is okay. Okay, let's check it. And then input your address, ask for the ETH. Okay. Uh, Let me change to another one. Okay. Because I already used that and our website to ask for some ETH today already. So they prevent me do again. Okay, I need to have some balance. So let me change to another account. So there are always some restrictions on it, but this need of balance is not much, just 0.001. So now the price of the ETH is nearly 5,000. So it only requires to have $1 worth of the ETH in your actual wallet. So as you can see, that meaning is that one private key can generate a certain public key, right? So that means on the Ethereum main network, you can have a address in this way here, for example, here my address. And on the Symbolian network, you can also operate the same address. Okay, that's why it requires me to hold at least 0.001, okay, ETH in the main network so that I can get a testnet token. And then I think, yeah, successfully get the 0.1 is civilian is. Okay, then I have the money to test my smart contract. Okay. Okay, now I have more similarly is. Okay. Then I can deploy this smart contract on the test network, the simply Ethereum network. So to do it, uh, in this window, change the environment to injected provider MetaMask rather than the remix virtual machine. Okay, and then it detects my another account. Okay, let me shift. Okay, so click this one. You can let me change. Okay, disconnect, disconnect, and reconnect. Okay, go back to the account 6, which contains more ETH, and then click the injected provider MetaMask. And then it gonna ask me whether to connect with this website from the MetaMask extension, and then you click connect. Then the website, the Remix, successfully recognized that I have this balance of the symbolic is okay, 0.16. Okay, and then click deploy. It will ask me to sign my transaction. Okay, then confirm. I'm actually already signed the transaction. Okay, the transaction has successfully been created. Okay, and there are two hyperlinks. Okay, in which case you can check these transaction on the Etherscan because one now deploying our smart contract really in a real blockchain network, right? Although it's a test network, but it's a real network. It's not the local simulation. So we can click view on Etherscan. We'll shift to Etherscan, this testnet explorer. We can see that just now we have deployed this smart contract, and the smart contract has address of this. Okay, so this transaction is for creating this smart contract. Okay, and this is some detailed information because we are only sending some encoded data, which is the bytecode, the code for the machine to read to the network. So the input data is just some bytecode. Okay, yeah. And this is the first step to deploy our smart contract. Okay, and then we see that here we can say here, remember the address of our smart contract. It's something like 0x5f11, right? And here we can see that we have a smart contract deployed at the address 0x5f1. Okay, so the same smart contract. And then we do the same thing. We assign the value to the variable we define at the beginning of the smart contract. So here we assign okay 21, and we click store, and another transaction has been sent, and then we need to sign it. Okay, confirm. Yes. Wait for a second because the network produced every blockchain every a block every 12 seconds. So let's check the transaction again. Okay, the status is still indexing. So let me refresh. Still indexing. So it's still being processing by the, oh, now it has been confirmed. Okay. Um, So as you can see that from the information, these a transaction contains the calling from this address. This is actually my address, my wallet, and interacting with the smart contract I deployed just now. And the information is also encoded information. The function name is store, but inside it is some encoded hash. But as you can see that at least I know which function is it is and the type of the input. Okay, it's not a fully encoded that you don't know what is happening at all. Here at least you know I'm calling the function named as a store. Yes, and this is how to create your first smart contract on the Remix user interface, and also to deploy it in the Shibuya blockchain. And then I gonna show you how to do it in the Python environment. Okay, so this is the Python environment. Okay, and before doing it, I still need to introduce some new things for you. Okay, this is these are some necessary developing tools you need to interacting with smart contract in the environment of Python. So first one is the Gnash. Okay, so this is a tool to help you to get the local fork of blockchain locally. Okay, and then use the local fork to simulate your transactions. So just like the Remix virtual machine in the Remix user interface. Okay, and also to use Python, you need to have the Web3 Py library installed in your Python environment. Okay, so in this case, you can use this Web3 Py to interact with a smart contract and simulate in the Gnash environment. Okay, and the testnet is Shibuya. I have already talked about it. Okay, and then we shift to the Python. Um, you can write a smart contract in the file ended with .sol, which means the dot solidity. Okay, so let's check what is inside. Okay, so the things are mainly the same. Okay, we firstly define the version of the compiler. Here I make the version more broad, so almost every version of the of the compiler can compile this very simple smart contract. And the name of the smart contract is called a simple storage. And at the first, we define a variable which is named as a Ethereum number. And the first function is also store. So we assign the input number to the variable. And then another function, similar to the case just now, is the retrieve. We check the value of the variable we define at the beginning of the smart contract. Okay. And this is the smart contract we write here. Okay. And then for the deploy, okay. So these deploy, we firstly to simulate locally. Okay. To simulate locally, we need to init local fork using Gnash, okay, in the terminal. So I'm gonna close my previous one. Here, the Gnash fork deterministic, which means that we fork the Ethereum blockchain. So the default setting is the Ethereum blockchain. We fork the Ethereum blockchain with some certain unchanged setting. The unchanged setting is the something like the bunch of a private key you can use to simulate. So let's init local fork. Okay, so in the terminal there are some information about the blockchain. So as you can see that there are some private key you can use to generate the transactions to simulate, okay? And you can use this bunch of the private key. And then before it, these are the necessary, oh, not this, only this one, the Web3 Pi. You need to install this Web3 Pi library to execute the following functions. Okay, firstly, you need to open and load the symbol storage solidity smart contract. Okay, here we write and store it in the same directory in the Python project. And then there is a certain function in the Web3 Pi, which is called a compile. Okay, here I import this function at the very beginning of the script. Okay, the SoloX from SoloX. This is another library, so you need to also install this SoloX library. Okay. So after calling it, all of the compiled version of the smart contract will be installed in the compiled Solana, this variable. And then we store the compiled Solana into a JSON, okay, the compiled code. And if you check the code, you can see that, let me make it better. Okay. Um, yes. So firstly, here is the ABI. ABI provides the format that people can understand how to interact with the smart contract. So here we can see that in the ABI, there are two functions defined. Okay. Two functions defined and one variable defined. The one variable is the favorite number we define at the beginning of the smart contract. And also it's a type, whether it's immutable, okay, whether it can be changed. And another function is the retrieve function. And the third function, the second function is the store function. Yes. And here is the bytecode, okay, bytecode, which is used to be read by the computer. Okay. Yeah, so this is all the information needed to interact with the smart contract. And then we go back. So as you can see that we extract the bytecode from the compiled code, okay, as well as API. Okay, so we use the API to help send a command to the smart contract. Okay, and we use the bytecode to construct an instance in the Python environment to interact with the smart contract. Okay, so because we have already init the Gauge local fork, so we need to connect the Python things to this Gauge local fork. We use the Web3 Pi. Okay, so here we create the instance of the Web3 Pi by inputting uh, this URL. Okay, this URL locates to the local blockchain we forked using the Gauge. Okay, and then for the private key, I input the private key from the environment file. Okay, so you can also doing this because it will protect your private key to be read by some others. Because if I just put my private key in the script, so everybody can see my private key. So I didn't show it here. I put it in the environment file. Okay, and then using some functions inside the Web3 Pi, you can actually do many things. Like using the private key, you can create the instance of the account, okay, in the Web3 Pi library. And you can also get the address or the public key of the this account. Just use just because this is one field of the account, this instance. Okay. So the first step to interact with the smart contract is to deploy it, right? So to deploy it, firstly, you need to create a Python instance of the smart contract. So you define the smart contract using the API and the bytecode. The bytecode is for the computer to understanding what it's doing, and the API is for how the users can interact with the smart contract. Okay, and then to estimate how much gas would be used by deploying this smart contract, and this is actually a local simulation already inside the local virtual machine. Okay. And then we calculate the nonce. Okay, the nonce is actually the cumulative number of transaction has been sent by a certain address. Okay, so here I use the function get transaction count and input my address. Okay, the my address is actually the count address. Okay, and then we build a transaction. Okay, here is some commands. Okay, comments. So if you want to execute a certain thing, three steps to go. Firstly is to build a transaction. The second is to sign the transaction with your private key, and then to submit the transaction or the sender transaction. So firstly, because we have already constructed a smart contract instance in the Python environment, right? So we constructed by calling one of the method in this instance, okay, the constructor, and then build the transaction. And then we input some certain parameters like we construct these or deploy this smart contracts from our address, our defined address. And then the nonce is the nonce calculated, and the gas is the gas estimated, and the gas price, as we explained, is this is the gas we want to pay for each unit of the gas to the validator or the known or the system. Okay, so we pay 5 GUI, okay, each unit of the gas, okay, and then we sign the transaction. So this can be executed by also another Python function, which has the name of a sign transaction, using our private key and the transaction define the first step, okay, as the input, and then we get the sign transaction, and then we submit the sign transaction, okay, here send the row transaction, and then we wait for a while, then we get the receipt of the transaction. If the transaction is succeed, then it means that the contract has been successfully deployed. Okay. And then after deploying the smart contract, we interact with the smart contract. Okay. So to interact with smart contract, we need the API because the API tells people how to interact with the smart contract, and the API it defines how the functions looks like as well as the variables, and also the contract address because the address locates the smart contract in the network. So we will know which smart contract we are interacting with. So uh, it's like in the network, you don't know anything. You submit some command to the network, and the network gonna find out which smart contract you are willing to interact with. Or analogy is that you are mailing you're mailing some people, right? And so you write down its address as well as the content in the envelope, and then you submit it to the to the poster, and then they will help you to send your mail to the one of the destination. So the same case here, the contract address tells the system which smart contract you are willing to interact with, so they can navigate your command to this smart contract. And the ABI tells the system in which way you want to interact with the smart contract. So the ABI is actually helping convert your human readable code to the byte code. Okay, so this is a point of this kind of two um, input. Okay, so here we because we have already deployed smart contract, so we create another instance of the smart contract. So the previous instance is for deploying that smart contract, and the second one is for interacting with the smart contract. So here we init this instance of the smart contract using the contract address, okay, as well as the ABI. Then at the very beginning, we call the function of the retrieve. Okay, remember that the retrieve function is a call function, so it does not spend any computation resources. So that's why we don't need to spend any its token to pay for the gas. Okay, so that's why there's nothing inside the input of this command. And then we want to call the store function to assign some value to the variable favoring number defined at the very beginning. And we want to assign the value of 15 to this variable. So as we can see from the smart contract we make, okay, so here the store has an input, okay, with a certain length, okay, with a certain length. And then we put the input of 15, and then we defined some input for executing the transaction. The chain ID, you can actually omit these parameters because the default value is the Ethereum chain ID from the address and the nonce plus one because we have already executed the last transaction to deploy the smart contract. So we need to plus one. Otherwise, your transaction gonna fail because you're double spending. Okay. And then we sign the transaction. Okay. Use our private key, and then we submit the transaction. Okay. And then yeah, and then the transaction gonna be executed. And then finally, we call the function retrieve again to see whether we successfully change the variable's value. Okay. And then this is the end. So let me execute the whole script to see whether the whole process could be executed successfully. Uh, Execute the Python. So it's a bit slow. So in the terminal, you can see that here the E is estimate gas is the function called by the commands inside the Python script. It cannot be okay. It seems stuck. I think it's because the gas price is too low. Okay, let's increase the gas price. So here the gas price is 5. Timeout. Okay, let's increase it to be 20. When the gas price is too low, your transaction will be waiting at the main pool for a very long time because all the other transactions has a higher gas price. So the builder will not select yours. What happened? Okay, let's restart. Yeah, sometimes you're gonna encounter some weird error when you're using the local fork because some confliction of the version, I think. Here, as you can see that the version is usually Shanghai. The hard fork version is Shanghai. Um, but the real Ethereum now is not Shanghai. It's already another version. So if there is some confliction of the version, there's some problem. Then we try again. Okay. So now we success. As you can see that here, two transactions has been executed. Okay. The first transaction uh, is a contract creation, okay, which means that we deploy our smart contract at this address, okay. And the second one is the calling of the certain function, okay. And the transaction hash is like this. The transaction hash is used to locate a certain transaction, okay. Yes, and in this way, we simulate our transaction. And in Python console, we can say that firstly, before assign value to the variable, the value has the variable has a value of 0. And after assign 15 to it, and then we call it, we can say it's a 15. Okay. And I also have a version of testing it on the Symbolia network. Um, but I don't know whether it will work because of the gas price um, problem also. So let me try it. I don't know whether in my wallet there are still enough Ethereum test token. Let's try it. So the content of the things are merely the same. The only difference is that now I'm submitting the transaction to the Symbolia network. Okay. Okay, the contract has been successfully deployed, and I have checked the value. Okay, it succeed. Okay, and then my address is like this. Okay, I use this address to interact with the smart contract, and then let's check whether how I succeed. Okay, so in the Ether scan, I checked my address. Oh, okay, okay. So just now, I deploy a smart contract. Here's the contract creation. And then I call the method store. Okay. Yes. So later on, I think I can push the code, the symbol code to GitHub and share with you the GitHub link so you can check the code. Okay. Yes. So any question?
Well, I think that at least we can say thank you very much. But also, the question would be like that. Ma, perhaps you have any advice how to learn, or maybe you remember how you started deploying your own smart contracts. What was your journey? So, how did you start doing that? And what would be your advice to incoming people who are only starting doing that?
My advice is to try the things by yourself, because like if I after I submitting this or pushing this script into GitHub, you can download it, right? And then you can play it with you by yourself, and maybe you have some question, and then you can copy this to GPT and ask it I think GPT is doing very well with this solidity code because this kind of thing is invented in 2015, so it has already been 10 years, and many people are writing this code. So actually, the GPT can answer all your questions related to these Ethereum things. Yeah.
And what was your first task? So how did you start it?
My first task, uh, it's a quite long ago. So this is actually the code when I'm learning the Ethereum blockchain. So this is my first script to this simple storage, and this is before my internship in the industry. So I think the time when I'm really learning something is the time in the industry I'm assigned a task to write a real, very complex smart contract. But at that time, there is really GPT. So I get help from GPT a lot. But I think without it, I cannot achieve many things at that time. Yeah, but thanks to it, I can. Yeah. So from the very simple things, you can get what the meaning of it. But don't think the smart contract is a very complicated thing. So it is just a script you can deploy it in the distributed computer, right? So if I change the contract to class, it's just like very similar things to some of you, I think. The class is you can say class in C or Python, right? So it's actually the same.
And maybe we can provide examples of such contracts. So, I mean, some interesting examples. Uh,
Um,
what
if you
what
are
could these smart contracts do?
if you want some real world example, I think you can just check the Ethereum scan, okay? Because there will be real world example. The Ether scan, and you click the block, any block you want, and the transactions. Because on Ether scan, many of the smart contracts are labeled. They labeled what the smart contract is doing and who owned this smart contract. Like here, this smart contract is called USDT stablecoins. So as you can see from the name, this smart contract is actually the USDT stablecoin use. Okay, let's click it, and all the code are publicly released. Okay, and you click the contract here, you can see all the code and the following, but it's very complicated.
So
Mm.
is it just the okay, so how many lines there?
Not many. Here is nearly 500 lines.
And what this smart contract does?
You can, oh, here you can check the things like read the contract. The read contract contains all the core functions contains in the smart contract, which means that you can retrieve data from the contract without consuming the gas. Okay, you can say that you can know the name of the contract. The name is Tether USD. Deprecated, not deprecated, still using. And total supply of the tokens this much, a very huge number. Upgraded address 0 means not abrogated, I think. And the balance, you can check any address balance. Like if you know someone else has some USDT, you can check how many USDT he has by calling this function. Because as you can see that in the smart contract, we're actually recording all the balance using the balance sheet. So each address will according to a certain value. Okay, and the decimals means the largest, the accuracy, I think, the accuracy, like the smallest unit of this token you have. And the maximum fee is the transaction fee. Sometimes there will be a tax, okay, something, but this is not relevant to most of the people. Allowed, okay, this is more complicated things for some complicated functions. So this is used for like sometimes we want the smart contracts to spend your money. Okay, so these function is actually to checking whether this smart contract is allowed to use some other people's money. Okay, a lot of functions. And also you can see the bunch of functions that change the status of the chain, like um, here transfer, okay? Transfer some money. So by transfer, you are actually changing the status, okay? You change the data stored on the chain. You change the balance sheet, okay? So that's why it's a you need to write, okay? Write into the storage, okay? Yeah. So this is the way to check smart contract without looking into the code. So just checking the functions as well as the input.
All right, pretty clear. So that was it. That was our third session. Today we discussed the major blocks and how the smart contracts look like, in general at least. In your home assignment, as I said, we will give you some really simple tasks, how to write your own smart contract, and also you will be able to use Ma's code and others code that you can find anywhere in the internet. And thanks to ChatGPT, I think that this task will not be really problematic for you. All right. So next time, what's gonna be next time?
Next Thursday, I think.
Yeah, I think that we gonna talk about your own token deployment.
Oh, I think I forgot to talk about the layer two, but I'm gonna include it in the next session. Not
Yeah.
much content.
And
Yeah.
I think that it's logical to talk about that next time because, well, your own token deployment. I think that the path that you're gonna choose is to deploy layer two token, not layer one, because layer one will be a bit painful, I think. All right. So, thanks for your interest. In half an hour, we will start another session in AI. And close to the end of the day, we will hand out the assignments. All right.